Hi everyone, I'm James, one of the student engagement interns and final year geology student here at the University of Glasgow. And something I've realised while studying here is that geology really is all around you. So today I'm going to take you on a bit of a geological tour of the campus, starting here at the main building. And instead of just showing you the rocks, which would be boring, I'm going to tell you how we start to interpret them and how they can tell us about the Earth's history. So let's get started. This isn't just architecture. It is a collection of rocks, each formed in completely different environments across hundreds of millions of years. Let's start with what you're standing on. These sandstones are from Arbroath on the east coast of Scotland, and they're over 350 million years old. So that's Devonian in age, a time when life wasn't even dominant on the land yet. They started as sand deposited in ancient rivers or floodplains, and then over time compressed into rock. The reason they split so cleanly into flat slabs is because of mica, a mineral that forms in thin layers. So in a way, the rock already knows how it wants to break. Now, the building itself is built out of local sandstone quarried here at Gilmore Hill, but interestingly, the grains are cemented by a mineral called calcite, which dissolves in rainwater. So that means that the older blocks here have had to be replaced by these newer sandstone blocks. So you're looking at geology and its failure here. And then within a few steps, you move from surface processes to something much deeper. This pillar is not made of sand, it's made of crystals, very distinctive pink crystals. This is granite from the Isle of Mull, and it formed from molten rock, magma, very deep under the ground, cooling for a long, long time. And it was this slow cooling that allowed for the crystals to grow so big that now the whole pillar looks pink. That crystal is called feldspar. So just by walking inside, we have gone from sedimentary rock formed at the surface to igneous rock formed kilometres below it. This sundial is said to have belonged to Kelvin himself. It's made of sandstone, but what's more interesting is what's on the ground below me. These blocks are dolerite, a volcanic rock formed when magma cools relatively quickly underground, faster than granite but slower than a lava. So that's what gives it a really tough interlocking structure, and that's why it was used to pave Glasgow streets at one point. So this is geology not just chosen for its story, but for its durability. These sculptures date back to 1690, older than the campus itself. And if you look closely, you can actually see ripple marks, as well as dark organic material in the sandstone, probably from rivers or tidal environments. So what you're looking at is a surface that was once underwater. The Davidson building is more modern, but it still uses natural stone. It is clad in a sandstone that comes from northeast England, Permian in age, around 250 million years old. And what's interesting here is that the building reflects a time where transport was improving, so stones started coming from farther away. So the buildings aren't just geological, they are historical records of technology and industry as well. And that's the thing about geology. Once you start noticing it, you realise that you're not just looking at buildings, you're looking at fragments of Earth's history coming together in the one place. And this is just the beginning. In the next part, I'll take a wander down to more modern buildings, including the Adam Smith Business School, and show that whilst they might not be built out of natural stone anymore, they're still hiding geological secrets. See you then.